Now we're going to talk about properties of math. These properties will probably seem pretty obvious to you, but it's because of these properties that we are able to always be consistent with math. So let's start with the commutative property. The commutative property states that it doesn't matter what order you add things in as long as you have all addition, or it doesn't matter what order you multiply things in as long as you have all multiplication. So the basic rule written algebraically for addition is A plus B equals B plus A. The basic rule written for multiplication is A times B equals B times A. So if you think of a really basic example, we know that 3 plus 4 is going to give us the same thing as 4 plus 3. Or 3 times 4 is going to give us the same thing as 4 times 3. So let's look at some other examples. If we start throwing in variables, we have 2x plus 4 equals 4 plus 2x. In this case, we have the commutative property of addition, and 2x would be our A, and 4 would be our B. Example, A times B equals C times B times A. Notice what happened here is that the order of A, B, and C changes. So I'm saying that A, B, and C being multiplied together can be multiplied together in whatever order I want. In order to recognize the commutative property, you'll notice that whatever happens on the left side, that on the right side you have the opposite order, or a different order. Another example is that x times 4 equals 4x. So x is some number times 4 equals 4 times some number. Or A times B equals B times A. Next we have the associative property of addition and multiplication, and it really states the same thing as the commutative property, only it's dealing with. So the commutative property deals with working from left to right with our order of operations. So for example, with the commutative property, if I have 2 plus 4 plus 8, it might be faster to add the 2 and the 8 together to get 10 and then add the 4. And the commutative property of addition is telling you can do that instead of having to work left to right, adding the 2 plus 4 first and then adding the 8. So the associative property deals with parentheses, because parentheses in our order of operations mean to come in here and do this first. In the first example with addition, we have A plus B plus C. And since A plus B is in parentheses, we are being told to go add A and B first. On the right hand side, since B and C are in parentheses, we are being told to add B and C first and then add A. So what this property is telling you is it doesn't really matter. If you have all addition, you could start with adding the B plus the C first, or you could start with adding the A plus the B first. So you could put parentheses wherever you want. So it means the same thing as the commutative. It's just addressing order of operations when you have parentheses. With multiplication, it's the same exact idea, only with all multiplication. So if you have all multiplication, it doesn't matter what order you multiply things in, as long as it's all multiplication. So we here could multiply A times B first and then C, or we could multiply B times C first and then A. Again, the associative property is there to address order of operations when parentheses are part of our problem. So let's look at some examples. In our next example, we have 3x plus 4 in parentheses plus y equals 3x plus 4 plus y in parentheses. Again, it doesn't matter if we add the 3x plus 4 first or if we add the 4 plus the y first. We'll get the same answer. Of course, in this example, we have all unlike terms, so you couldn't really add them together. Example, we have 5 plus 6x plus 2x, where on the left-hand side, the parentheses let us know that we need to add 5 and 6x first. On the right-hand side, we have the same order, 5, 6x, and 2x being added together, but the parentheses ask us to add 6x and 2x first. So which side could we actually complete if we were going to be adding? What do you think? We could complete the right-hand side but not the left. Why is that? On the left-hand side, 5 and 6x are not like terms, so we could not start this problem out by adding 5 and 6x. We would have to add 6x plus 2x. So we would have to complete the problem the way that the right-hand side of the problem asks us to. So again, the associative property is telling you it doesn't matter what order you add your numbers as long as you have all addition, and it doesn't matter what order you multiply your numbers as long as you have all multiplication. Therefore, it doesn't matter which two numbers you put your parentheses around to emphasize the order of operations. So what do both the commutative property and associative property allow you to do? So let's look at this example here. We have 4 plus y plus 5, y plus 4 plus 5. So are they in the same order? Are these numbers 4, y, and 5 in the same order on the left as they are on the right? No, they are not, because what switched order? The y and the 4 switched order on the right-hand side. So therefore, we're seeing a demonstration of the commutative property because the order of the numbers changed. What about the associative property? Are we seeing the associative property? Well, 4 and y are in our parentheses on the left-hand side, and we know we can't add those first because they're not like terms. So instead, on the right-hand side, we went ahead and put the 4 and 5 in parentheses because those are like terms and we can add those first. So this is demonstrating the associative property as well, because what is inside the parentheses is different from the left-hand side to the right-hand side. So when we're changing the order, like we did from the left-hand side to the right-hand side here, with all multiplication or all addition, that demonstrates the commutative property. When we are changing what's inside the parentheses from the left-hand side to the right-hand side, that is demonstrating the associative property. Again, both of these properties are telling us it doesn't matter what order we add in, and it doesn't matter what order we multiply in, as long as we have either all addition or all multiplication. And the commutative property deals with the order of the numbers, working left to right as part of our order of operations, and the associative property deals with parentheses, which is the next part of our order of operations. So for example, if I have 2 times 7 times 5, it's actually easier to multiply 2 times 5 first, because that gives us 10. So which property tells us that it would just be easier to multiply 2 times 5 first? Well, since we're not dealing with parentheses, this would be the commutative property because we changed the order of the numbers. So this is the commutative property of multiplication. I'm going to abbreviate. In the next example, we have 8m plus 3m in parentheses plus 7m. And that's easier as 8m plus 3m plus 7m, because 3m and 7m equals 10. It's just a little bit easier with our addition. So what property tells us we can leave these in the same order but put parentheses around the ones we want to do first? This would be the associative property of which one? Of addition, right? Next example. 4x plus 3 plus 7x is easier as 4x plus 7x plus 3, so that we can add our like terms. So did the order change? 4x, 3, 7x, 4x, 7x, 3. Yes, the order changed. So what property is that? Commutative property. Did the numbers that we have inside the parenthesis change? Yes. So that's also which property? The associative property. And these are both going to be of what? Addition. All right, let's look at another example. We have 2xy times negative 3xy is easier as 2 times negative 3 times x times y times y. What we're doing is demonstrating what we actually do when we multiply in our head. We multiply our coefficients, then we multiply our same bases, and then we multiply our other same bases. So when you do this in your head, what property are you using, or properties? Well, the way I have it written out here, we definitely changed the order. So which property is that? Commutative property of multiplication, right? And I did put parentheses in this problem. I didn't have to, but I wanted to demonstrate it with parentheses. So which property would that be? We're demonstrating with the associative property of multiplication as well, because we have parentheses around different numbers when we actually complete the problem than when we first started with the problem.